And the theory behind the Docker. What is Docker? Docker is more of, let's understand what is Docker, history behind it, why it all started off, is it really required, and all those things. Okay. Let's understand the problem. As we saw, why the virtualization world started, because there was a problem of resource wastage. Okay, we were buying too many hardwares, and we were wasting it because we were not using it efficiently. Okay, that's where the concept of virtual machines started off. But then, if you talk about Docker. Docker is an open source project that automates the deployment of applications inside software containers by providing an additional layer of abstraction and automation of operating system, a level virtualization on Linux. So what exactly is happening? Keeping this diagram, let me explain you a little bit. So till now, we have seen this part. Always, till now. I have a host, I have a server, I have a hypervisor, I have a guest operating system. This would be Windows, this would be Linux. It has its own binary files and then application. But the problem is, if at all, I have A application and B application for which this both are actually the same, common. I still have a separate virtual machines for every application, right? In a production environment, it makes sense, no problem. But in a development environment, it doesn't make sense. Okay. For second thing, if I have to, if I'm doing a development, 40% of the time in the industry, the development is done on a new project. The remaining 60% of the development work is actually done on a existing production setup. Okay, if you ask the companies, creating something on a creating a new thing is much more easier when compared to creating something or upgrading the current production environment. So that was a so in a virtualization world, what is exactly happening is, for every application which I want to build, I need a separate operating system. Even though it is repeated, same binary file, I still use it. So this part of it, it's getting repeated. That is one thing. Second thing is, whenever I am trying to do a development on my production system, I don't do it on the production. I take a copy of the production and I have to do it on my staging servers and then put it on the production. When I do the staging server, that's exactly the problem, because 90% of the time I might not get the number of virtual machines, the same number of virtual machine where I have it in production. If I don't have the isolated virtual machines, same number of virtual machines, how do I imitate the same setup of production, and how do I make sure the development work which I do is actually going to work in the production system after the development is done? These are the two big challenges which we started facing. Okay, the solution to this was containerization. Containerization is not a new concept. It's been there for the last 15 years now. The whole idea of containerization is application containerization. Now think this as a container. Don't for now let's forget this is a Docker. Okay, just think as a container. So I install a server. Either it could be a virtual machine or it could be a machine sitting on a physical hardware. Okay, it could be anything, no problem. So what I do is I install a container software on this virtual machine. Okay, basically 15 years back when it all started off, it started on Linux. Okay, we call that as LXC, Linux containers. Okay, so the idea is now this I can install this application inside a container with the required binary and libraries from the host. Okay, so this is a closed container. This might require only 100 MB of memory. Okay, similarly, I will install one more container and install application B, which will take again the binaries and libraries from this host. It takes a copy of it while it is building a container. These two containers, even though they exist on the same virtual machine, they don't talk to each other. They are completely isolated. And this property solved both the problems what we just saw, which is a big problem in the industry. When I say big, it is wasting billions of dollars creating a new virtual machine for a similar kind of application. Similar, when I say similar, they're not the same, similar. These two applications are almost similar. Like this is Tomcat, this is like WordPress, but both needs same Linux OS with the binary files and everything. The only thing is I have to create one more. But with this case, I can have just a container on the same host machine. Maybe this container is using 1 GB and this is using 1 GB of RAM. And the host is using like 3 GB of RAM or 2 GB of RAM. So I save the 2 GB into multiple times of application which I create on this. This is called containerization. What is Docker? Docker is an advanced level of containers. When the container started off 15 years back, it was a plain simple application containerization and it couldn't do anything else. It still depends, even today it depends everything on the host. It's a parasite. I call the containers as parasite because it sits on the host. It cannot exist without the host operating system, like a Windows or a Linux. But today, the Docker is self-sustained. It has its own networking properties. It has a lot more features when compared to a container, which was Linux container, which was 15 years back. What did Google do? When the Linux containers concept started off, it started implementing that in their environment. And in 2013, that is where they released Docker as an official open source product, which they have been using for a long time in their environment. So Google is the owner of this Docker engine, okay? And today, the Docker is grown to an extent where I can have a separate application running, a web server with an IP address, and I can access this IP address from outside. I can have a separate web server here with an IP address. I can access that separately outside. So I'm running multiple applications, isolated applications on a single virtual machine. You see to an extent what I'm virtualizing now. It's crazy stuff. It's just crazy stuff, right? So this is Docker, which needs almost 128 GB RAM. Okay. Why will I create a container and create a 128 GB RAM? I rather just put 128 GB RAM on my host machine and dedicate this MySQL server for the production. Why will I put it in the container? The container is giving a miniature of the production setup for me to emulate the production setup and do a development work. That is the precise requirement, and that is what the Docker is solving. On from Linux containers, multiple isolated Linux systems on a single host. That was the idea behind. Today we can run Docker on any various Linux or Windows distributions. Okay, and also I can run Docker on any of the cloud providers. That is the flexibility, because Docker today can replace it. We are expecting that in some cases, as I said, it can even replace a hypervisor. Okay. So this is how you run a simple Docker system. So there are multiple terms which you need to understand in a Docker world. Okay, the terminology, the first terminology is image. Okay, what's an image? Image is nothing but, as I told you, it creates a container. So before it creates a container, it creates an image of it. What is an image? In AWS, you have seen whenever you create an EC2 instance, you create it from an AMI, which is an image. What is an image? So it is a ready-made operating system which has preloaded stuffs. You just uncompress it, correct? So that's your image. Similarly, before you run a container with specific applications, first you create an image out of that. So when you create an image, the image is going to install all the required components for that application, all the required stuff for that, and then it's going to create an image. Once it creates an image, the image stays there, and you can create n number of containers from that. Not one, n number. As you create a EC2 instance, multiple EC2 instances from the same container, you can also create multiple when you create EC2 instances from the multiple EC2 instances from the image AMI, you can create multiple containers from this Docker image. By default, there is a repository of Docker image in docker.io. Also, you can create your own custom images. Okay. The next thing is the next command which you need to understand. Run. Create a container from an image and execute a command in it. Okay. Tag an image. Pull. Download image from repository. Okay. RMI. Delete a local image. These are the 5 commands which you use. Before this, the command you use is Docker. I mean, you say Docker images, Docker run, Docker tag, Docker pull, Docker RMI. Okay. Similarly, these are very similar to your Linux commands. These are containers. Once you create a container, there are certain functions which you can do on the container. Okay. That is your PS. PS is list all running containers. Okay. PS-A, including the stopped container, it will show you all the containers. Display processes of containers, top, start a container, stop a container, pause a container, RM, delete a container, commit, create an image from a container. Okay, so if you want to create an image from a container, commit is also another command apart from run. So we saw in the previous create a container from an image and execute a command in it. This is run is nothing but you can create a container from the image and you can execute a command inside the container as per your requirement. If you're running a Linux based container, Unix based container, or a Ubuntu based container, you can pass certain commands which you want to run inside the container. Okay, this is commit is nothing but just creates a container doing nothing. So this is your base image. For example, you would have created another image out of it. Okay, you would run a container with certain things. Then you can say you can modify those containers and then say commit, which is going to create a new image. Okay, from here I can run more containers. So you see the cycle. I can create an image, create a container, then update the container, a new state, and then commit it as an image, and then I can create new containers out of it. I can do that, right? So that's the flexibility which I get, and I hope you understand the difference between an image and a container, which is very, very important. Okay. You can either run a Docker command in a single line, say Docker run blah blah blah, or you can build a script called the Docker file. The name is always the Docker file. Okay, you should always keep the file name as Docker file. You will always create it inside a folder, and for every image which you want to create, you will create a Docker file separately. Only for the image creation. When you create a container, you will create a container from that image. Can be subversioned in a version control system like Git or SVN along with all dependencies. Okay. Docker Hub can automatically build images based on Docker files in GitHub. That's crazy. Okay. So the Docker Hub is nothing but your centralized repository. Okay. Online repository for Docker. It can automatically build images and keep the images in your Docker Hub once you upload the stuff. This is an example Docker file. So it says, let's understand what this example is trying to do. Today, I'm just going to show you the examples. In the next class, we'll go through the complete practicals because it needs almost 1.5 hours, which I have to showcase you. So here, if you see from Ubuntu, this is the Ubuntu system which I'm going to use. Then I'm saying environment, say hello my world, add a directory called files, which is inside the container, and then say some scripts, bash some scripts. I can run some scripts here. And then I'm going to say Docker build the Docker file directory. You see this? This is a Docker file. This is a Docker file directory which will have this Docker file. And then inspect the image just to check whether the image is created or not. And then finally, I can say run this Ubuntu to create a, this is to mount a volume. I can mount a volume from my local machine to one of, inside the container to one of the folder. Very, very nice stuff. So now you understand how a local machine and a container talks to each other. Some folder on my local machine can be mounted. This is another reason why I'm not using Docker as a production system, because there are the Docker image containers are accessible from my host machine. So by mistake, if somebody gets an access to my host machine, means they could gain access to my Dockers, which is not a great stuff. So that's another reason where today I don't have much control over the Docker's networking and security part. But yes, to an extent, some people are still using for a mini services in their company Docker as their production system. Run second container volume can be shared between those containers. Publish a port. Say, for example, you are running a web services inside your container. So this is your web service inside your container at port number 80. On your main physical host, you can say map it to 8080. So on my, how do I access? Go to the host IP address, put :8080. I will be able to access the web page inside the Docker. We are going to do this labs as we talk. I mean, I'm just showcasing you how things are. And then I can do a link container. And there is something called Docker Hub. That's where all your Docker images are there. Docker for VMs, automated setup. You can integrate Puppet, Chef, and Ansible along with the Docker to do bigger things. It also has an ecosystem with SkyDoc and SkyDNS. This is your hub.docker.com. I expect you to create an account in hub.docker.com. Everybody, there's a public repository. You can see what kind of images are already there. It has an automatic build from Docker file. Source for build is available. Docker use cases, development environment, environments for integration tests, quick evaluation of a software, microservices. Okay, this is where the Docker is used. Multi-tenancy. Say, for example, I told you, right? Previously, what is happening is on GoDaddy, when you create a website, do you think you have a dedicated hardware? No, it's a shared hardware. But the problem with the shared hardware is if somebody hacks into the physical hardware, physical server of that web server, they could gain access to the other websites. But with the help of Docker, I could create an isolated network and I can manage it separately. Okay, that's a fantastic thing to do, right? Unified execution environment, dev, test, and then go to prod, local VM, cloud. Okay, So if you see here use cases, it's 99% it is more for evaluation, integration, test and development and microservices and all those things. Is that clear? So we will do the practicals tomorrow. We will see how to install Docker, how to create a simple image, how to create a custom image, what are the things which you need to remember, and how to play around in the networking a little bit. Fair enough? Course, but I personally suggest get into Docker and Kubernetes as deep as possible. That for an administrator, it gives you a wonderful edge to get you a job. So today, there's a huge demand in the market, huge, for Docker, Kubernetes, and Python. Just these three things. If you know a little bit of scripting on Python, and if you know how the Docker and Kubernetes works, there are crazy amount of requirement just to do that. Containerization. Because every developer will look at you. Can you just containerize my application? Can you test it for me? Yeah. So that's a crazy stuff which is happening right now. Make sense? Just given an introduction to Docker. Okay, so tomorrow.